This talk will take a look at the system services provided by OS2 to use in developing your application. While John Pollock doesn't intend it as an exhaustive list of the over 1,000 OS2 system calls, it does cover the most important functions in the new operating system. Grouping the calls by function will make it easier to appreciate the completeness of the functionality provided to you by OS2 when you're designing your next application.
I'll be talking about OS2 application services. Application services in OS2 divide into two main categories. There are kernel services and presentation services. And we'll talk about each of those services in turn. First, we'll talk about the kernel services. In the kernel of OS2, there's a way to allocate and deallocate memory. Memory management is segment-oriented. The type of things you have available to you in the memory manager are things like allocate segment, free segment, release segment. Importantly, there are a few new calls that people have been waiting for a long time. There's a call called DOS allocuge. This allows you to allocate and deallocate the megabyte arrays. There are routines called DOS giveseg and DOS getseg that allow you to share memory. These are new services that haven't been available before, and those are the highlights of the memory manager. So we have, in review, we have a segment-oriented memory manager. And that memory manager provides for the allocation of large arrays and the resizing of those arrays and the sharing of the arrays. Another major feature of this new operating system, and we've talked about it before, is the tasking features of the operating system. There's a need to process information asynchronously, and there are a set of services that allow you to do that. These services are divided into two main categories. The first category is the process. A process is a set of files, a collection of memory, and a priority. The second set of services are what we call the thread services. These allow you to start up multiple paths of control in your program. So we have two different things. We have a set of resources called a process, and then a path of control through the process called a thread. Lastly, within the tasking, we allow you to query the system and find out about the tasks. And this is through a call called get DOS infoseg. For example, you can find out what your process number is, what that process's parent is, what, if that process has children, how many threads it has, etc. Additionally, you want a level of control over your processes or your programs. You can get their priority and you can set their priority. These are services that people have wanted for a number of years, and we do have them. So reviewing, we have a collection of resources called a process. There's a scheduling entity or a path of control through a process, and that's called a thread. You can control the scheduling behavior of threads. If we have tasking, we have memory management, there's a need to communicate between several programs that are executing simultaneously. We do that through inter-process communication. And this is where OS2 is particularly rich. It has any number of excellent communication mechanisms. We'll go through them very briefly. First, we have semaphores. These are standard computer science semaphores. We have two flavors of them. We have fast in-memory semaphores, and we have named shared semaphores. But they're what you learned in school. They're very common. We have a thing called signals. Signals are asynchronous interrupts, software interrupts, and you can use them to communicate between programs. We have the classic Unix method of inter-process communication, and that's called a pipe. So those people who are Unix programmers should be able to do everything they've been able to do before. We also have an inter-process communication that is new for many programmers called the queue inter-process communication. Our queues have the properties of standard computer science queues. You can have first in, first out queues, first in, last out queues, or priority queues. But they can be used to transfer information between processes. The review is, and what I want to get across to everyone in the audience, is that OS2 contains all the classical means of inter-process communication. We don't think we've missed anything, and each of the means of communication has its place. If you need fast inter-process communication, you'll probably go with semaphores, in-memory semaphores. If you want transparent inter-process communication, you'll probably go through pipes or through queues. Okay. In input-output, there should be no surprises in OS2. There are several calls that are new in OS2 that you will like, but in fact, there's nearly a one-to-one correspondence with the old or familiar 3x, 2x DOS. There's a one-to-one correspondence between new calls and old calls. The things that are new and are normally convenience items. The new calls are read asynchronous and write asynchronous. You can start a read and write operation and have it complete independently of your program. There's a call called DOS new size, which allows you to resize a file, and a call called set max file handles. The resizing of a file and the setting of max file handles are things that have been requested for many, many years in the DOS, and we've simply provided them. But there is essentially no new information that you haven't had in the past. It simply uses the new dynamic link interface, and this will be new to you. There's a way to deal with time in OS2. The only new calls are the start timer and stop timer. Other things you're familiar with. You're also allowed to put your program to sleep with a call called DOS sleep. In the DOS, there's a thing to deal with the environment. The environment can be resized. You can get the environment, and when you do get environment, that gives you back a selector, and that selector can be passed to the memory manager and resized bigger or smaller. You can also get the DOS version. So in the past, the environment size has been hard to deal with and has been a limitation. It is not a limitation anymore. The DOS also provides a means of doing error processing. These are the in message, get message, push message. They're rather vanilla. I won't say much more about them. Okay. So we've seen at this point all the new DOS calls, or the kernel services available for OS2 programming. The theme I want to stress is that there's a one-to-one correspondence between old 3x, 2x calls, and what new calls we have are directed at generating new tasks or new processes, enhancing communication between those processes, or correcting errors in the old DOS, and essentially fixing mistakes of the past. So you should be well at ease. It should be fairly easy for you to map one for one your old programs to the new environment. We'll go now to the presentation services part of OS2. This is new. This is all new functionality, and it's all graphically oriented. For many of you, this is the first time you will have ever seen this. The first service that the presentation manager provides is a segment suballocation package. At the beginning of this talk, we said that the DOS provided for segment allocation. Well, there's a need to partition those segments into smaller pieces and to manage those smaller pieces. The presentation manager provides a set of routines to manage that suballocation. Those people who have written Windows apps will recognize these calls as mapping to the Windows suballocation package, one for one. Their names are taken or modeled after the names in the C runtime library. Pascal programmers will look at these and say, and map alloc memory to new and free memory to dispose. So there's a need to take these large segments and to break them up and to manage the small pieces, and Presentation Manager provides a mechanism. The next larger piece of the Presentation Manager is the graphics shell. This is one of the harder concepts to come by, and I'm not going to go through individual calls, but I will give you an idea of what it's there for. The graphics shell provides a means of building lists of programs. You put a program onto the program list, you can take a program off of the program list. Once a program is on the program list, you can bind other programs to it and create a group. You can then, with the mouse, select individual programs or groups of programs and activate them. These are the add program, change program, add to group, create group, destroy group. The idea behind this set of calls is that you should be able to put a name on a list and bind a program to the name. And the name might be John Pollock's special program for calculating the day of the week, and that may be actually be bound to an executable called zip.exe. But I should be able to select the program by the name I give it, rather than the name the manufacturer gave it. You should be able to start a program by that name, and you should be able to create groups of programs and start them all at once or put them to sleep all at once. For example, you might have a favorite spreadsheet or a word processor or a stock market analysis package, and you want all of those three programs to start up at once because that's your daily activity. You can do that, and that's what the new shell is provided for. There's a whole set of routines here called that are the switch list and the grouping routines that manage those activities. And we go through them very quickly. We'll just cover the slides. Okay, so there's a great deal of functionality, and we don't want to point out them individually, but we want to point out that you can build lists of programs, bind programs into groups, give those groups names, and start them and stop them en masse, and that's very convenient. So we have, in review, simply a central mechanism for quickly switching between programs or groups of programs. The next set of functionality in the Presentation Manager is the message processing calls. We've stressed this quite a bit in the seminar. And this is our review slide of what we've covered. The biggest part of the Presentation Manager is the windowing capabilities of the Presentation Manager. And those capabilities are divided into subsections. The reason we like to do this here is this is the one place where the functionality of the windowing code is broken up into pieces. Okay, in the reference manuals, it's done alphabetically, but in this presentation, what we do is we break it up into logical pieces. The input for the presentation manager is done using keyboard, and when you type a key, you get a message to your application, and that message is WM Care. The format of this message is a scan code, flags, a repeat count, character, and virtual key. The important point is that if you wish to, you can process raw scan codes rather than WM Care. That information is available to you. You also get a flags byte, which tells you characteristics of the character that has come in. Was the character a downstroke? Was it an upstroke? Did someone have the Alt key pressed when the key went down? You have a great deal of information comes in on WM Care, and it allows you to distinguish between all possible states of the keyboard. The mouse is handled in much the same way through a set of messages. The mouse comes in as WM mouse move, as a message from the presentation manager, followed by a message such as WM button 1 click, button down, button up. To summarize the mouse, what you get is when the mouse is moving, you get WM mouse movement messages. When a key on the mouse goes down, you get a mouse 1 button, a mouse 2 button, a mouse 3 button. Okay, and again, you get messages and flags to tell you whether the key was going down or going up and which key it was. The format of a mouse message is get WM mouse button 1, 2, 3 or mouse movement followed by the X, Y position of the mouse at the time the key went down. So, to summarize, the presentation manager handles input with messaging, and you get two major types of input. You get keyboard input or you get mouse input. In order to get input at all, you need a window, and there are a set of routines for creating and manipulating windows. You can register the characteristics of a window. You can get the name of those characteristics. You can create a window and you can destroy it. As we pointed out, a window is made up of various parts. Associated with the window are identifiers that allow you to identify the parts of a window, and this slide gives you their names. If you've created a window from registered characteristics, then you're able to make it visible and invisible, and there's a call to do that. If you have windows are rectangles, and there's a common set of routines that you can use to manipulate those rectangles. I don't think we've missed a single rectangle manipulation capability. You can copy a rectangle, you can see if one rectangle is equal to another. You can offset a rectangle by a certain amount, et cetera, et cetera. The set of things you can do is quite extensive. If you have a window and you are getting input and you can manipulate it with the rectangle routines, then there's a time when you'll want to control whether or not input is going to the window, and there are a set of routines to do that. When enable window enables the window for mouse input, and when enable update enables the window for painting. So you can turn the painting of a window on and off, and you can turn its responses to the mouse on and off. You can also control the mouse and keyboard input on a broader level by finding out which window is currently processing input by using get active window, and you can change the window that is using input using win set active window. That level of control is extended to the mouse. You can control mouse input by saying win get capture and set capture. This is confusing to some people. It's sometimes the first time you've ever heard use the term capture, and that always refers to the mouse. Keyboard, you can control the keyboard the same way. There's a way to become the center of keyboard activity. And there's a way to query the state of the keys. Okay. And these are the set of calls that are responsible for doing that. When you become the center of keyboard activity, we say that you get the focus and you set the focus. The other routines on this slide are for querying the state of the keyboard. So to summarize at this point, if you're talking about controlling activity of the mouse, we use the term capture. If you're concerned with controlling the activity of the keyboard, we talk about the focus. There's a need in the presentation manager when you go write programs for country to country to adjust the output by the country. And there are a set of routines that allow you to programmatically change the behavior of your program depending on which country you're in. Name of the month, days of the week, currency symbol, date and time format. The separator, do you use a comma or do you use a period in numerical calculations? That type of thing is provided by a set of routines. Once you have a window and you're controlling its input and an output, you'll need to change the attributes of that window. Perhaps you'll want to flash it. Perhaps you'll want to change its border. There are a whole set of routines that are specifically exported to deal with that. So there's a way to inquire the state of a window. You can find out whether a window is visible or invisible, what its class is, whether it's a window at all, whether it has children, etc. All windows operate by getting messages and acting on those messages. If you don't wish to process a message, it has to go somewhere. You have to do something with it, and that's handled with win default window proc. Occasionally, there's a need to enumerate or to do processing on a whole series of windows. To do that, we have a thing called the enumeration procedures, where you tell the system you wish to begin on a series of windows. Then you say, I want to visit each window, and then you say, I want to stop visiting the windows. This is called window enumeration, and it's useful if you want to paint a series of windows. It's useful if you want to change the caption on a series of windows. In fact, or perhaps visit every window in the system. The last query functions are those things that have to do with setting the default characteristics of the window. For example, the caption. You can set the caption and get the caption. You can manipulate the default data inside a window with get window word, set window word. You can get the default colors for a window. For example, you do not know what the background color is, but you can say get system value, and it will tell you what the background color of a window is. So, in summary, there's a whole set of routines available here that allow you to get and set the attributes of a window. Importantly, you can visit every window in the system by using the enumeration routines. Sometimes it's necessary to look at the relationships between the windows, and there are a set of routines for doing that. Win window from ID, win multi-window from ID, get a window, set the parent, get the owner, lock the window. The important point here to note is that there are a set of query functions that allow you to determine the parentage of a window, and that is important. There's a means in the presentation manager for changing the shape, size, and position of a window. Set window position and set multiple window position. Because the window system is composed of hundreds of windows, you would like to be able to set the position of those windows in mass. And set multiple window position allows you to do that. An esoteric topic, but perhaps an important topic for you, is that every window has associated with it a procedure to process messages for that window. Some of those procedures are created by Microsoft, and you don't have access to their source code. Sometimes those procedures don't do what you want them to do. Our interpretation of what the procedure is to do is not what you want it to do. There is a means called win subclass window that allows you to intercept that procedure and change its behavior, so that if you do not like the behavior of our default window procedure, you can change it. And that is called subclassing. There are a few miscellaneous routines in the window manager. There is a way to initialize a window. There is a way to tell the system you're done with a window. You can flash a window. And then there are two routines called catch and throw, which are the set jump buff, get jump buff calls that you're familiar with from the C runtime. Now, those are all the primitives. We've covered all the primitives so far for manipulating windows you create. Sometimes you don't wish to go to all the trouble of constructing programmatically a window. You'd much rather program from templates. And there are a set of routines in the presentation manager which take a diagram or a template and create a window from it. These are called dialogues. And there are a whole set of routines for load a dialog box, load a dialog from a file, and from that template create a window that is the representation of the template. You can send messages to the dialog, you can get information from the dialog, you can enumerate all the parts of a dialog. To sum up, it's simply important to know that you can create a template in ASCII form and load that template, and the windowing system will create the windows and take care of all the nitty-gritty work for you. Same thing is true of menu. Menus can be created from templates. Occasionally, programmers make mistakes, and there's a need to report errors. And we have a standard error reporting window called the win message box window for doing that. We also have a way to beep the bell on the computer and a way to report errors. A window is composed of many parts. It has an outside border. It has a sizing box. It has a caption. It has various pieces. You're allowed in the presentation manager to make those pieces one at a time. The outermost piece is called the frame. There are a set of routines for manipulating the frame. Between applications, there is a need to exchange information in some standard way. The kernel routines for the DOS allow you to grow your own per program communication. Some people don't want that. They need some standard means for doing that. And we provide a thing called the clipboard, which is a standard means of transferring information between apps. You can open the clipboard, close the clipboard, set the owner of the clipboard, put data on the clipboard, take it off the clipboard. So we have one standard mechanism that we've devised, and if you wish to use it, you may. Otherwise, you can grow your own using the kernel routines. Sometimes you'll find that we did a good job in our behavior of our programs and the way we process messages, but sometimes we just didn't do it right for you. And what we've provided is a series of procedures that allow you to change the behavior of the system in a dramatic, global way. These are called the hooks. Sometimes you simply need to change the way the system behaves in a global fashion. And you do that by saying set hook, release hook, and calling the message filter. The common hooks that are available are the input hooks, the send message hook, the journaling hooks, the help hook, and the message filter hook. Perhaps the two most interesting are the journaling hooks. Using the journaling hooks, you're allowed to capture every keystroke in the system and every mouse movement in the system, and then play those mouse movements back and the keystrokes back. This allows you to do demonstrations on your machine for trade shows. It allows you to write computer-aided instruction for your product, and that's the one you'll probably be most interested in. If you have a window, there's a need to highlight text, and that's called the caret, and there are a set of routines for bringing the caret forward and putting it back. There's a way to highlight the mouse position. That's called the cursor routines. You can load a cursor, create a cursor, show it, set it, get its current position, etc. So you may perhaps, we normally have an arrow for the mouse cursor, but you may want to have an X, or you may want to have a target. You may have a lot of things, and we allow you to change it. Lastly, in terms of highlighting, there is a way when your window becomes very small, you wish to have a symbol for that window. That's called an icon, and there's a way to load an icon, set an icon, and move it. One of the more important parts of the presentation manager, now that we have covered ways of creating a window and of moving it and setting it and finding out its shape and size and moving its position, eventually you want to paint something into that window. You want to draw something. There are a set of routines that clip your window and allow you to paint into it. And there are a very large number of them. Anything that has, on this slide, anything that has region appended to it means that it's a routine intended to control how clipping is done in the window. There's a way to scroll a window, there's a way to track the cursor in the window, there's a way to begin the painting of a window and to end the painting of a window. In fact, you have quite a bit of control over how the windows operate. So eventually you're going to want to paint, and there are a whole set of routines that allow you to paint and control the painting of your window. In international scene, there's a need to process strings in different character sets and encoding. This slide gives us the different character manipulation routines. In particular, Japanese ASCII is a 2-byte code, and getting from previous character to the next character requires some special care, and there are routines built into the presentation manager to allow you to do that. So presentation manager is designed for not only Indo-European languages such as French and German and Italian, but also for languages such as Japanese or Chinese, where the character sets are very large. We have a means to manipulate bitmaps in addition to characters. Not surprising, everyone uses bitmaps in this industry. Within the presentation manager, there are a number of address spaces, different coordinate systems. There are routines to manipulate those coordinate systems and to translate between them. There are window from point and win map window points. This allows you to map between all the coordinate systems in the presentation manager. Another topic is in the windowing system, there are times when you'll want to draw attention to a particular window, and that's called its modality. So there's a means within the presentation manager for making a single window the focus of all activity, and that's set system modal window. For example, when an error condition occurs, you want to make the error window the focus of all activity, and you want something to happen in that window. And there's a means of making that window the sole window in the system. So, to review all this information about windowing, and there's a tremendous number of calls for windowing. The windows are virtual display devices. They're recursive. They're resources that you create and give back. And windows are the focus for all input and output messages. Presentation Manager also has a means of taking care of time. Whereas in the kernel, timer messages or timers are handled asynchronously as if they were interrupts or traps. In the Presentation Manager, time is taken care of by passing messages, and there's routines called start timer and stop timer that turn timer messages on and off. One of the nicest things about the Presentation Manager is you can configure the Presentation Manager such that certain programs are loaded at boot time and certain programs are run in boot time, and there are a set of routines for doing that. You can find which programs simply to load, to be ready to execute, and you can set which programs you want actually to execute. Lastly, there are a set of routines called atoms. There's a need to convert strings to numbers and numbers to strings. Strings are very long, expensive items. This mechanism is called the atom mechanism. It is not a symbol table. The idea is you take a string, you pass it to the atom manager, it hashes the string and returns a number. That number is called the atom. And there are a set of routines for doing that. You use the atom routines whenever you want to pass a unique number between processes. In summary, I'd like to say that the OS2 Presentation Manager is a rich, rich interface. It's extremely flexible. It takes time to learn, but it's worth the effort, and you'll get a lot out of it. Thank you.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this videotape.